Hi, welcome back to Networking Fundamentals. This is Instructor Gregory, and today we're going to cover Module 2 of Understanding Local Area Networks. Alright, so let's go ahead and review our agenda and get started. So we're going to cover understanding network topologies and access methods. And in doing so, we're going to review what network topologies are. Alright, now we're going to also talk about Ethernet standards. Now, these are the standards that govern Ethernet communication. And then lastly, we're going to talk about peer-to-peer versus client-server models. And we'll detail both of these models in contrast to one another. Alright, so let's move forward and talk about network topologies. A network topology defines the physical connection of hosts in a network. Now, there are multiple types of topologies, and we have bus, star, ring, and mesh. I'm going to show you each of these right now, and I'm going to talk about how they function. All devices in a bus topology are connected by way of a copper cable in a line. Now, let's take a look at this example that I have below. If computer 1 wants to send data all the way down to computer 5, it has to send data through computer 2, computer 3, and computer 4, and vice versa. Now, this is not the most efficient way to send data. Alright, next we also have the star topology. Now, this is an advancement over the bus topology. Each host is connected to a central connecting device like a hub or a switch or a home router, right? We talked about those earlier. And this is the most commonly used topology that you're going to find in an office setting, or even in a school setting, or even at home, all right? Now, note that you can actually connect two of these star topologies to each other by way of a central connecting device, and that topology is actually called the star bus topology. Next, we have a ring topology. Now, each device in a ring topology is connected to another. And note that each device is actually connected to two other devices. So let's take a look at our example that I have below. If I have computer 1 here, it's connected to computer 7, but it's also connected to computer 2. And that's a pretty neat setup. We also have a mesh topology, and that's pretty fun. Now, one thing I want you to note here is that there's no central connecting device, right? And that's super important when discussing a mesh topology. Now, this setup requires that all computers, right, or each computer is connected to all other computer within the local area network, right? So it can be a pretty intensive setup, and if you're wiring and cabling all of those computers and connecting them to each other, right? Now, the great thing about a mesh topology is that it's fault tolerant, all right? So let's look at the example here. If I'm at computer 1 and I want to send data to computer 2, and that direct connection between us happened to fault, well, I have multiple other connections, right? I have multiple other options for sending my data to its intended destination, and that's fault tolerance, okay? That's part of what makes a mesh topology such a great thing. Alright, so let's talk about Ethernet standards. We connect multiple computers to each other by way of copper cabling. And there's a standard that governs this process, all right? Ethernet is simply a standard. It defines how data is sent and received between devices, right? And this is the most widely used standard on the internet, right? It's used all over the globe. Now, there are a couple of other standards that are used though. All right, you have a token ring in which each device actually has to have or possess a piece of data called a token in order to be able to send data on a topology. There's also the FDDI, which is a topology used for fiber optic communication, right? But Ethernet standard is governed by the Institute of Electrical and Electronic Engineers, right? The IEEE. I want you to write that down because you're going to hear that a lot, right? It's also referred to as 802.3, okay? So write this down. Ethernet is governed by the Institute of Electrical and Electronic Engineers, the IEEE, and it's referred to as 802.3. Okay? Now, devices that use the Ethernet standard transmit frames, and frames contain physical address information that helps a switch to determine where to send the data. Okay, so a switch don't actually send data using the IP address, right? A switch will send the data, or they navigate the data by using a MAC address or a physical address. And we'll talk about a MAC address here in just a second. All right, so before we move forward, something that is very important for you to note. 802.3u and 802.3ab are the most commonly used versions of the 802.3 standard, okay? I do want you to take some time to recall and lock that in, okay? Because this is going to be very important moving forward. This chart that I have provided to you, I'll make it available to you in your notes so you can have it for yourself, all right? But I want you to look through this chart, look through all the versions of your 802.3, and look at the data transfer rate and the cabling standard and the cables used with these standards, and just lock it in, all right? It's very important moving forward. The 802.3 defines something called a carrier sense multiple access with collision detection. Now, you'll usually see this referred to as a pretty lengthy acronym called the CSMA/CD, right? And what happens with this is that devices share a common connection, right? If they send data at the same time on a connection, collision can occur, right? Think of this as you're traveling down a one-way road, okay, and you're driving a car, and your friend is driving a car in the opposite direction, so you guys are both driving towards each other, right? If you couldn't shift to the left or to the right, you guys are going to run into each other, right? And that would be a very bad thing. And that actually happens with data, all right? So you could have two electrical pulses run into each other, and all of a sudden the data is corrupted and no one is going to receive data, right? So your text messages get lost, and something is wrong, and that might happen. So keep that in mind. All right, so the key to remember is that with CSMA/CD, only one computer can transmit data at a time, okay? So let's talk about this collision, all right? The CSMA/CD process. If a computer wants to use the Ethernet network using CSMA/CD, it's going to assemble a frame, okay? It's going to listen to an Ethernet cable to see if the medium is free, all right? And if it's free, it transmits a bit, all right? And if it's not free, then it goes back and it listens. And then if a collision is detected, it implements something called a collision detection procedure. Now, what is this collision detection procedure, okay? Now, if a collision detection procedure is detected, the network adapter will perform the following steps. Now, I want you to write these down. First, it sends out a jam signal to stop all communication on the medium, okay, through the network, all right? Then it's going to wait on a number of collisions detected. And then after that, it's going to start sending the remaining bits of the frame. Okay, so that's a three-step process. It sends out a jam signal, okay? It waits on the number of collisions detected, and then it's going to start sending the remaining bits of the frame. All right, so let's switch gears and talk about the client-server model, okay? And we'll also talk about the peer-to-peer model as well. The client-server model depends entirely on devices called servers. All right. Now, servers are computers that are dedicated to providing specific types of services or data, right? And a client like your computer or like your cell phone is going to use a special software to ask the server for a data or a service, okay? It's going to say, hey, can you provide me, or can you please send me an HTML file? I would really enjoy that. And then the server will respond by providing that data or service to the client, right? Now, this model is commonly used, and really you're probably using that right now to watch this video. All right, so let's talk about the different types of servers, okay? Now, there are file servers, print servers, database servers, and network controllers, right? So if you're working for a school district or you're working for a large company, there's a domain that you probably have an email address for, and that means you have a user account, and network controllers are used to manage that data, right? There's also messaging servers and web servers, which are used to access HTML documents, right? And there's also something called the CTI-based servers, which are for telephone and computer systems. So if you have voice over IP, you're probably using a CTI-based server, all right? It is important to note that your client operating systems are going to be different from the types of operating systems that are used by your servers, okay? As you can see from the table below, these operating systems provide slightly different functionality, and so they serve different purposes, clearly because clients and servers also do. All right, so let's discuss a peer-to-peer model. A peer-to-peer model is different from the client-server model because it doesn't have a server, okay? Peers are just client computers, and they all have equal capabilities and responsibilities, all right? So each has the ability to send and receive data, all right? So we have like Skype and voice over IP, and we also have cloud computing, which use peer-to-peer models. Okay. You may also find file sharing networks like Napster. I'm not sure if some of you remember Napster if you're old enough. I think it's still around, just in a different form. And then you have the Gnutella and the G2s. But what you need to remember is that each computer accesses and requests data from its peers and not from a server, okay? So there are two different models that you'll see on your journey through networking, a client-server model and a peer-to-peer model. All right, so let's do a quick recap of Module 2. We focus on understanding network topologies and access methods, and we talk about different network topologies. We also talk about the CSMA/CD Ethernet standard and just the Ethernet standard in general. And we also talk about peer-to-peer and client-server models. All right, so thank you so much for joining me for this module, and I really look forward to seeing you in Module 3.